Sorry about the bell. So today's lecture is about multi-step unit conversions. We've been doing single-step unit conversions, and some of you have been finding them not too bad. And so we're going to move forward with some slightly more complicated ones that I think that we can all handle. So here we go. As a review of the things that we have done in the past, we have used the idea that the unit conversions, we always have to start by determining what relationships are needed. Then we write our given value over 1. Then we set up a conversion factor. And then we write the unit of the given value on the bottom of the conversion factor so that they cancel out. We then go ahead and fill in the rest of our relationship, cross out units that will cancel. And now we're going to get into something that's a little bit different. It's a new part. And so we have to repeat steps 3 through 6 until we end up with our desired unit. So there's going to be more than one fraction here. Then, just like before, we would multiply straight across and then simplify. So, a quick example, something that's not too complicated, says that a scientist measures the time it takes for an insect to crawl. Certain distance is 2 hours. So the insect, little bug, goes a certain distance in 2 hours' time. But the problem is that the scientist needs to use this time frame in his calculations as seconds. So he has to go ahead and convert them to seconds. So the way that he's going to do that is he's going to change hours into minutes, and then he's going to change minutes into seconds. And so we have to remember what our conversion factors are, and because these are hours and minutes, what we're going to do is it's not too hard to remember that 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. So when the scientist would set up this particular problem, the scientist would take the 2 hours and put it over 1, just like we've done before. So that's our given piece of information. And then we would try to change hours into minutes, and then we would change minutes into seconds. And so that the way that would end up looking is he would have a fraction here and a fraction here. So the next thing that's going to happen is the scientist is going to set the conversion factor up so that hours will cancel out just like before, and as a result of that, he's going to put hours on the bottom. So he's going to put hours on the bottom, and he's going to put minutes on the top. So he's using the relationship between hours and minutes. So he's going to put 1 hour on the bottom and 60 minutes on the top. He is then going to convert from minutes into seconds, because if he stopped his calculation right here, the units of hours would cancel out and he'd be left with minutes, but he needs to get to seconds. So the way he's going to do that is he's going to now put minutes on the bottom, and he's going to put seconds on the top. So Miss Salati just checked in, saw how things were going. She'll be a sub for 1 of your hours today. And anyway, we have minutes on the bottom, so I'm going to put the value of 1 minute on the bottom, and then I'm going to put the value of 60 seconds on the top. So now what I'm going to do is I'm going to check to make sure that I have units of canceling. So my units for minutes cancel, and I'm left with seconds on the top. So my math is just like before. I'm going to multiply straight across, and I'm going to then divide or simplify. So I'm going to take 2 times 60, hit enter or equals, and then times 60 again and hit enter or equals, and I'm going to get a value that's 7,200 seconds. So it took that little tiny bug to travel whatever distance it happened to travel in 7,200 seconds. Not too bad. Now we're going to make it just a little bit more complicated, because we're going to use units that are metric. So I'm looking at this problem that says we are going to convert 35 kilometers into centimeters. So we have to identify, first of all, what our base unit is. So in this case, I see meters and meters. So that means that I'm dealing with meters. And as a result of dealing with meters, that means I'm measuring in length. Okay, and so I have to figure out the thing that links kilometers to centimeters. Well, if I think really hard about that, I'm going to take kilometers and convert it into the base unit of meters, and I'm going to take meters and convert it into centimeters. So those are my relationships. So that tells me that I need to remember that the relationship between kilometers and meters is 1 to 1,000. And the relationship between meters and centimeters is 1 to 100. So when I go to set my problem up, I need to convert from kilometers to meters and from meters to centimeters. So that tells me that I'm going to take my 35 kilometers, put it over 1, and I'm going to go kilometers to meters, meters to centimeters. So if I'm going to go to meters, the first thing I have to do is make sure that my units of kilometers cancel out, and I put kilometers on the bottom, and I'm going to put meters on the top. So now that I'm checking to make sure that my units cancel, I see that kilometers cancel out, and if I stop my calculation right here, I will get a value in meters. So I'm going to put the amount of kilometers in the conversion factor and the amount of meters in the conversion factor that make them equal. And now I'm going to move one more step and convert meters to centimeters. So again, I'm going to take my meters and I'm going to put them on the bottom, and I'm going to convert to centimeters and put that on top. So then I have to go back and check to make sure that my units cancel out. So I'm looking at this and saying, well, meters cancels out, and I'm left with centimeters, which is what I'm trying to find. So I'm going to fill in the values. So in this case, I know that 1 meter is equal to 100 centimeters. So I'm going to take 35 times 1,000 times 100, and I'm going to get, let's see, what am I going to get here? 3,500,000 centimeters. And hopefully that huge number makes a little bit of sense, because I'm going from kilometers to a much, much smaller value. So hopefully, like I said, that makes some sense. All right, another example. Now I'm going to go from milliliters to kiloliters. And again, I'm going to look for the base unit that's the same. So in this case, I have liters. So that tells me that my base unit is liters, which is measurement for volume. Okay, so now I need to figure out my conversion factors. So I'm trying to figure out the relationship between milliliters and liters, and the relationship between kiloliters and liters. Well, according to what I've been taught before, I know that 1 liter is 1,000 milliliters, and 1 kiloliter is 1,000 liters. Okay, so now I'm going to set this problem up, and because I'm going to go from milliliters to liters, and liters, liters to kiloliters, that tells me that I'm going to have a 3-step problem. So I'm going to take my 3,275 milliliters, put it over 1, and go from milliliters to liters, liters to kiloliters. So in this problem, I'm going to put milliliters on the bottom, liters on the top, because I need them to cancel out. I'm going to fill in my values, 1,000 milliliters and 1 liter, and check to make sure that my units cancel, like so. I'm then going to go one step further and put in my liters on the bottom and my kiloliters on the top, and I'm going to go ahead and fill in my values and then check my units to make sure they cancel. And now I'm going to do some math. So I'm going to multiply straight across, and when I multiply straight across, I'm going to be left with 3,275 kiloliters over 1,000 times 1,000, which is 1 million. And then I'm going to simplify. So I'm going to take 3,275 divided by 1,000,000, and I'm going to get a value of 0.003275 kiloliters, which I probably should have done in green, so I'm going to write that up here, 0.003275 kiloliters. Cool. One more problem to show you. This time I'm going to go from centigrams to grams. So going through the same process, I'm going to identify that the common base unit is grams. Which is the unit of measurement for mass. Now I'm going to go from centigrams to milligrams. Well, here's how I would like you to do that. I would like you to convert centigrams to grams and milligrams to grams. I would like you to do it in these two steps. Don't try to do it all in one, okay? So the relationship between centigrams and grams is 1 gram is equal to 100 centigrams, and 1 gram is equal to 1,000 milligrams. So when I set this problem up, I'm going to take 74 centigrams, and I'm going to go centigrams to grams and grams to milligrams. So that tells me that I'm going to have a two-step conversion factor problem. So again, I'm going to put my centigrams on the bottom and my grams on the top, and going to fill in my values. So I have 100 centigrams and 1 gram. Check to make sure that my units cancel. I'm going to now continue filling in my units, and I'm going to have grams on the bottom and milligrams on the top. And I'm going to fill in my values and check my units, and they do cancel. And I'm going to be left with, I should have done that in this color, because colors are fun. Okay, so I should have done milligrams and 1,000. Okay, so now I'm going to multiply straight across, so 74 times 1,000, and I get 74,000 milligrams divided by 100, and I get 740 milligrams. So the actual answer here is 740. So that is how we do these multi-step problems. They're not too bad. You just have to identify what your base unit is and then convert to the unit you're trying to find. Good luck. Your homework is to do the two-step problem worksheet, and that will be due tomorrow.